Think of your stomach as a house. On a normal day, it's a climate-controlled, stable environment. But depending on what you put on your plate and how you sleep, that house occasionally ignites. We call this structural fire heartburn. The accelerant for this fire is gastric acid. Your body naturally produces this corrosive digestive fluid to break down food, but heavy late-night meals cause it to surge past its natural volume and boil over its boundaries, scalding the lining of the stomach wall. While the acid burns, a digestive enzyme called pepsin amplifies the destruction. Pepsin thrives in high-acid environments. When your stomach's acid levels spike, this enzyme begins actively chewing through the proteins that make up your stomach lining. When lifestyle habits fail to cool the system, the body enters a state of acute crisis. To prevent a collapse of the stomach's structural integrity, a chemical intervention is required to extinguish the fire. That intervention comes from antacids. These medications function as a chemical fire brigade, rapid response units designed for immediate symptom control inside the gut. Their effectiveness relies on their identity as weak bases. A weak base is a chemical compound that only partially ionizes in water, allowing it to absorb hydrogen ions when deployed into the highly acidic environment of the stomach. This illustrates neutralization. The weak base collides with corrosive acid molecules, converting them into harmless water and salt. As the pH scale rises above 4, a secondary effect triggers. The pepsin enzyme loses its acidic environment, causing its jagged structure to collapse, stopping stomach damage. This buys the body immediate relief, but achieving that survival requires a temporary forced alteration of the stomach's fundamental chemistry. To execute this override, the fire brigade relies on a battalion of 4 specific active ingredients: the hydroxide and carbonate compounds of aluminum, magnesium, calcium, and sodium. Deploying these specific metals introduces a biological cost. When aluminum hydroxide is used to fight the fire, the compound slows the motility of the intestines, leading to severe constipation. Using magnesium hydroxide causes the exact opposite extreme. Magnesium draws excess water into the intestines, which results in acute diarrhea. In the megaldrate synthesis, scientists fused aluminum and magnesium into a single molecule, hydroxymagnesium aluminate, canceling out their opposing digestive effects. This supermolecule is paired with additives like simethicone to break down gas, or oxethazine to numb the stomach lining during intense pain. Solving the primary biological crisis in the stomach frequently requires this level of pharmacological refinement to avoid engineering an entirely new problem in the lower digestive tract. Sometimes the threat moves from the stomach itself to the esophagus. When the valve between the two fails, corrosive fluid escapes upward, damaging the unprotected tissue of the chest. While neutralizing the acid treats the burn, a physical barrier is necessary to keep the fluid out of the esophagus entirely. This barrier is created using sodium alginate, a natural carbohydrate extracted from brown seaweed. Sodium alginate is a specialized unit that reacts instantly when it contacts acidic stomach contents. This simulation shows the sodium alginate transforming into a thick, gel-like raft. Because this raft is lighter than the liquid below it, it floats directly on the surface, creating an impenetrable lid that physically blocks acid from surging upward into the esophagus. This creates a layer of architectural protection, using the physics of buoyancy to stop a chemical problem before it can migrate. Relying on this rapid response system for long-term relief introduces a hidden consequence to the way the body processes other medications. Antacids have a very short duration of action. The relief often fades as soon as a meal is processed, which can force users into a cycle of repeated, constant dosing throughout the day. This diagram shows chelation. Antacid metal ions act like magnets, aggressively binding to and caging passing drug molecules. Blocked by these antacids, antibiotics like fluoroquinolones and tetracyclines become too large to pass through the gut wall, rendering them useless. The cycle of dosing for minor stomach discomfort can inadvertently neutralize the very drugs required to stop a systemic bacterial infection. Chemical interventions are designed to erase symptoms in seconds, but treating the flame is not the same as fixing the environment that allowed the spark to catch. The chemical fire brigade can extinguish the burn inside your stomach, but it cannot rebuild the damaged walls of the house. Long-term health relies on dietary modifications and lifestyle changes that prevent the fire from igniting. By managing portion sizes and sleep positions, you remove the excess fuel from the system. Lasting recovery isn't found in how fast you can put out an internal fire, but in building a body that doesn't burn down in the first place.